Hi, I am Anusha. I am a fourth year PhD student. I'm really excited to be a part of Mauve, and I am doing a project on massive stars with Mauve's data, and I'm really looking forward to it. There are multiple aspects to Mauve that I personally think as a PhD student I could have an advantage. For starters, bigger telescopes have a very rigid process of acquiring data. There is a specific timeline, and we are required to be completely clear of the science case and have a clear idea about the targets that we want to observe and apply way ahead of time to secure a spot on the observing schedule. I do think that Mauve gives us a little bit of room to experiment with newer ideas, also the ability to alter and change targets, learn what is working and not working, get an opportunity to experiment with ideas that are potentially less feasible through other means. So that edge is really exciting. Class of objects that we are working on are massive emission line stars. These are really giant hot stars that have a gaseous decretion disks. These are basically main sequence objects. So the disk around these objects do not have any dust in them. It's just ionized gas, and the material in the disk is actually ejected by the central rapidly spinning star itself. For years, we know that these objects exist, and we don't know why they exist, why they form that disk. And the disk seems to come and go at timelines that the star is pleasing. So we are just curious little crowd who just wants to know why there's so much drama in their life. And we intend to explore one fundamental aspect about these class of objects to understand whether actually these objects are rapidly rotating or not. And we're trying to quantify, if they are rapidly rotating, what are the rotation rates. And the ultraviolet region of the spectrum gives us a unique niche in understanding the effects of rotation, particularly the flux differences on the surface of these stars can be more accurately captured in these shorter wavelengths, the wavelengths where Mauve is observing. And we are trying to understand with better models what the literature was lacking. So that's the overall idea.